Okay, so let's unpack this. If you're trying to understand our place in the universe, or if you just need a reminder that science is really driven by wonder, there's one voice that, well, it just stands out.
Carl Sagan.
Carl Sagan. A voice that rings with, equal parts enthusiasm and this really necessary skepticism.
It's genuinely hard to overstate his impact. We are going to take a deep dive into the professional and profoundly personal journey of the man who became, I think you could argue, the single most influential science communicator the world has ever known.
And the numbers, they're just staggering. I mean,
Yeah.
his 1980 television series, Cosmos, A Personal Voyage.
Yeah.
It was viewed by over 500 million people
Mm-hmm.
across more than 60 countries.
Wow.
That is a truly unprecedented global reach for a show about, astrophysics and planetary science.
And that reach, that immense celebrity that came with it, that really forms the core paradox of Carl Sagan's professional life. On one hand, you have this global icon, a Pulitzer Prize winner, the face of scientific humanism. But on the other, his reception back in the academic ivory tower was much more polarized.
Right. A lot of his scientific peers were deeply critical of him.
They were. They saw him as too broad, maybe too much of a showman. Some even accused him of self-promotion instead of, pure research.
So our mission today is to connect those dots for you. We're going to synthesize his rigorous research. And, he published over 600 scientific papers.
An incredible number.
With his demanding role as this relentless public advocate for critical thinking. We want to show you exactly how his philosophical convictions and his scientific contributions were, they were intertwined.
And why his perspective remains so vital in our information-saturated world today. The central question we're really tackling is, how did that Brooklyn kid, born into a pretty modest family?
His father was a garment worker.
Exactly, a garment worker. His mother, a homemaker. How did he rise not only to become the David Duncan Professor of Astronomy at Cornell, but to achieve that level of profound global influence? It's a journey that was built on a foundation defined by this tension between intense curiosity and rigorous skepticism.
Carl Edward Sagan, born in Bensonhurst, New York City, 1934. And his early life, based in that modest urban apartment, it was really shaped by two parents who provided that perfect intellectual balance.
That parental dynamic was absolutely crucial to his development. The family, they identified as Reform Jews. And while his father, Samuel, wasn't overly religious, his mother, Rachel, was very active in their temple and kept a kosher home.
But it was more than that, right? It was about these two modes of thought he said they gave him.
That's it. He spoke about it beautifully. He said his parents taught him the two uneasily cohabiting modes of thought that are central to the scientific method: skepticism and wonder.
Skepticism and wonder.
Exactly. His father provided this example of, practical empathy and social engagement. Samuel was known for helping the poor, mediating labor tensions. And his mother, Rachel, she provided the intense, rigorous, analytical side.
She was a frustrated intellectual, wasn't she?
Absolutely. Her own ambitions were blocked by poverty and the social constraints of the era, and she just channeled all of that intellectual energy into nurturing Carl's curiosity. Biographers often say she worshipped her only son, believing he'd fulfill the dreams she couldn't.
So you have this dual nature, the analytical rigor from his mother, and this broad humanistic wonder from his father. And it all comes together in one definitive moment when he was just 5 years old.
The solo trip to the public library.
Yeah.
He was obsessed with a question that nobody in his circle could answer. What are the stars? And so, armed with a library card, he goes and asks the librarian. And the answer, that the sun was a star that was just close and all the other stars were distant suns, it just stunned him.
He called it a kind of religious experience.
Yeah.
For him, it wasn't just a fact. It was a total reordering of his personal universe.
And that realization, that sense of infinite scale and possibility, it never left him. That moment was really the emotional fuel for everything he did afterward.
And that sense of awe was cemented just a year later, in 1939, at the New York World's Fair. He had these incredibly vivid memories of the exhibits, which to his young mind were just pure magic.
Right, like the famous America of Tomorrow exhibit.
With a moving map of a future city, all highways and skyscrapers. But what really got him was the abstract science. He remembered seeing demos where a sound wave from a tuning fork would become a picture on an oscilloscope.
Or how light shining on a photocell could create noise. And this is a really fascinating nugget for you to think about because it reveals the intellectual blueprint for his later work. He wrote about it, asking, how could a tone become a picture and light become a noise?
So this obsession with converting signals
Was the origin of his lifelong interest in communication theory. signal intelligence, which was absolutely vital for his later work in SETI.
And crucially, the fair heavily promoted the burial of a time capsule.
Filled with 1930s mementos, yeah.
So that exposure to the idea of packaging human civilization into a durable message for a future audience, whether that's terrestrial or extraterrestrial, that directly inspired his greatest public achievements.
The Pioneer Plaque and the Voyager Golden Record.
Exactly. His childhood literally contained the seeds of his professional purpose.
And this is all happening against the backdrop of World War II, a deeply anxious time. His parents were desperately worried about family caught in the Holocaust in Europe.
His sister said their mother was fiercely protective of him, trying to shield him from those horrors.
And Sagan reflected on this in The Demon-Haunted World. He talked about that conflict between trying to keep that youthful, optimistic spirit while also confronting the brutal realities of what humanity is capable of.
So moving into his education, he was recognized as exceptional very early on. Straight-A student at Rahway High School in New Jersey, but, consistently bored.
His intellect was just undeniable. His teachers actually urged his parents to find a school for gifted children, but they just couldn't afford it. It was during his junior year that he realized astronomy wasn't just a hobby, it could be a paid career.
And he didn't waste any time. He graduated in '51, voted most likely to succeed, and was accepted into the University of Chicago's honors program at just 16.
Yeah, that was partly due to the university chancellor's program that embraced this sort of ideal meritocracy with no strict age requirements.
And his academic performance there was just explosive.
I mean, he racked up multiple degrees, a Bachelor of Liberal Arts in '54, a Bachelor of Science in Physics in '55. Then he does his graduate work immediately, submits his doctoral dissertation, Physical Studies of the Planets, and has his PhD in astronomy and astrophysics by 1960.
And he also worked on a thesis about the origins of life with the chemist Harold Urey.
He did, which becomes important later.
Speaking of his early work, we have to pause on this almost unbelievable fact that as a student, he was involved in classified, high-stakes military science. Tell us about Project A119.
Right. Project A119 was a top-secret United States Air Force plan conceived in 1958 by a team that included Gerard Kuiper, who was actually Sagan's dissertation advisor.
And the plan itself was just terrifyingly simple.
It was detonate a low-yield nuclear warhead on the surface of the moon.
And the purpose was just to show the Soviets we could do it.
Precisely. It was a Cold War propaganda exercise, a visible, undeniable demonstration of military superiority, meant to boost American morale and maybe intimidate the Soviet Union if they beat the U.S. to the moon.
And Sagan was directly involved.
He was. He worked on calculations about the expansion and visibility of the dust cloud that would result. He held a top-secret clearance with the Air Force at the time.
But the truly incredible part is the security breach that came out years later.
Yes. The project was shelved, but Sagan, in 1959, when he was applying for a postdoctoral scholarship to UC Berkeley, he inadvertently included the classified titles of 2 Project A119 papers in his bibliography.
Right.
The project director later confirmed that specific leak, and it just highlights this intense early conflict in his career, his deep involvement in secret Cold War military projects, which contrasts so sharply with his later public persona as an advocate for scientific transparency and international cooperation.
So he moves from Chicago to a Miller Fellowship at Berkeley, consults for the Rand Corporation, and then gets an offer to lecture at Harvard.
Which he successfully leveraged into an assistant professorship. He spent several productive years there in the 1960s, but then 1968 comes and it delivers this defining, really devastating professional blow.
He was denied academic tenure at Harvard.
This is a foundational moment we really have to unpack because it directly shaped the rest of his career. I mean, he was an active researcher, an advisor, a popular lecturer. So the denial was a huge personal surprise. It wasn't about a lack of research.
It was about his approach to science. The critique was that he focused his interests too broadly.
Instead of becoming a renowned expert in a narrow traditional specialty, which was the expectation at Harvard, that's the institutional critique.
But there was a personal factor, too.
There was. Nobel laureate Harold Urey, his former graduate mentor, wrote a deeply negative recommendation letter. Urey was what you'd call an old-time empiricist. He was very wary of grand theorizing.
And he saw Sagan's willingness to speculate openly about the unknown, about extraterrestrial life, about oceans on Europa, he saw that as a betrayal of scientific rigor.
Exactly. For Harvard, that broad speculative approach, combined with the perception of self-promotion from writing popular books and appearing on TV, it was just incompatible with their tenure standards.
So you have to think about what this means. This wasn't just a rejection, it was a philosophical clash between two different ways of doing science.
It was, and Harvard essentially forced Sagan into the public role he would later occupy. By rejecting the generalized big-picture thinker who communicated widely, they ensured that he had to find his validation and his platform outside that traditional academic structure.
That denial must have been a bitter pill, but as the cliche goes, when one door closes.
A planetary observatory opens. He was very quickly welcomed at Cornell University.
Right.
Cornell, and particularly the department led by Thomas Gold, was just far more flexible, more forward-thinking. Gold understood that Sagan's growing public visibility was an asset, not a liability.
He was offered a full professorship, a huge validation.
It was, and he accepted it, arriving in 1970. He would go on to spend nearly 30 years at Cornell, becoming the David Duncan Professor of Astronomy and Space Sciences and directing the Laboratory for Planetary Studies. That environment allowed him to fully integrate his research with his public advocacy, the very blend that Harvard had explicitly rejected. This move really created the Carl Sagan we all know today.
So once he's established at Cornell, free to explore all these wide-ranging interests, his scientific contributions, despite the academic criticisms, were just foundational, especially in the emerging field of planetary science.
He was defined by this. This was a major breakthrough, both technically and intellectually. And the crucial validation came very quickly with the NASA Mariner 2 mission in 1962, which confirmed his surface temperature calculation.
And here's where his activist science really begins to emerge. He didn't just see Venus as some interesting remote world.
No. He saw it as a natural laboratory providing a dire warning for Earth. He explicitly linked the runaway greenhouse effect on Venus to the potential for man-made global warming right here.
Which was revolutionary thinking in the 60s and 70s.
It was. He was among the first highly visible scientists to take that complex atmospheric physics and apply it to a human-caused environmental crisis. And this led directly to him testifying before the U.S. Congress in 1985 about the dangers of unchecked greenhouse gas emissions.
His knack for spotting potentially habitable environments extended further out, too, to the moons of Jupiter and Saturn.
Specifically Titan, Saturn's largest moon. Sagan hypothesized that Titan might have oceans on its surface, not of water, but of liquid compounds like methane and ethane. He also identified that its reddish haze was probably caused by complex organic molecules, the precursors to life, constantly raining down.
And maybe even more famously, Jupiter's moon, Europa.
Right. His hypothesis that Europa might possess subsurface oceans of liquid water kept warm by tidal heating made it a prime candidate for a habitable environment.
A hypothesis that was later, indirectly validated by the Galileo spacecraft data, which showed evidence of liquid under that ice crust.
And it just illustrates his gift. He was always spotting the environments, the places where the chemistry of life, even under extreme conditions, might just find a foothold.
His work on Mars was equally significant in steering the science away from romantic speculation and toward rigor. For decades, people had argued that the shifting colors on the Martian surface were signs of seasons or even vegetation.
And Sagan proved otherwise. He correctly determined that those variations were simply the movement of fine-grained surface dust, shifted around by these immense high-speed Martian windstorms.
So he demoted these beautiful, mysterious changes to just geology and meteorology.
Applying skepticism to romantic speculation, once again. And this rigor extended to the very origins of life. He's recognized as a pioneer in exobiology, or as we call it now, astrobiology.
He did practical experiments, right?
Absolutely. He demonstrated in the lab that amino acids, the fundamental building blocks of life, could be produced just by exposing basic chemical components to energy sources like radiation. He was showing that the spontaneous origin of life's basic chemistry was chemically plausible under the violent conditions of early planets.
And this leads us directly to the search for extraterrestrial intelligence, or SETI. This was still considered a fringe pursuit by a lot of academics.
But Sagan worked tirelessly to give it respectability. He approached SETI not as science fiction, but as radio astronomy, a signal detection problem.
His credibility was such that he's still the most cited SETI scientist. But the real game changer was his advocacy.
The petition published in Science in 1982 is a perfect example. He leveraged all of his scientific and social capital.
He convinced 70 highly respected scientists, including 7 Nobel laureates, to sign a petition advocating for the validity of SETI research.
And publishing that in a flagship journal like Science was a powerful public statement. It vastly increased the field's academic respectability.
But the work he's most famously remembered for in this area involves the physical messages he helped send into space. True interstellar artifacts.
These were designed as durable, redundant time capsules. The idea was they had to be understandable by an intelligence completely unlike our own, maybe millennia in the future.
The first one was the Pioneer plaque.
Attached to the Pioneer 10 and 11 probes, launched in 72 and 73, it was a gold-anodized aluminum plaque, and it was an exercise in pure scientific communication.
What specifically did they include?
It showed a diagram of the hydrogen atom's hyperfine transition, a universal standard of distance and time. It showed the figures of a man and a woman next to the spacecraft for scale, and a map showing Earth's position relative to 14 known pulsars.
Right, the pulsars act like galactic lighthouses.
Exactly. They pulse at rates that change predictably over cosmic timescales, so any finder could determine when the Pioneer probe was launched.
Incredible precision, packed onto a tiny metal plate. And the next message, with the Voyager probes in 1977, was even more ambitious.
The Voyager Golden Record. This was his ultimate communication challenge, co-curated with a team that included his third wife, Andrew.
A 12-inch gold-plated copper phonograph record. A summary of Earth's diversity.
It contained 115 images, sounds of Earth whales, volcanoes, the wind, and 90 minutes of music from across cultures, plus spoken greetings in 55 languages.
And it wasn't just showing off. It was about conveying essential facts of geometry, chemistry, and our location in a universally intelligible format.
And while those records are still traveling, he also helped write a non-physical message. The Arecibo radio message beamed into space in 1974. He helped Frank Drake write that transmission.
Which was basically a short, coded blast of binary info.
Pure symbolic logic put into a radio wave, conveying information about human DNA, the solar system, and the Arecibo antenna itself.
His proximity to the space program was just constant. He was an advisor to NASA from the 50s onward, briefing the Apollo astronauts before their flights to the moon.
He was deeply embedded in mission planning, but he also wasn't afraid to challenge NASA's priorities. Later in his career, he often argued that the excessive funding for the space shuttle and the ISS came at the expense of what he believed was more scientifically valuable.
Which was?
Unmanned robotic planetary exploration. He was always advocating for the science, not just the showmanship.
So by the time the 1980s arrived, Sagan had already won the Pulitzer for The Dragons of Eden and established his scientific reputation. But it was television that just transformed him from a famous scientist into this irreversible global cultural phenomenon.
The vehicle, of course, was Cosmos, a personal voyage. Premiering in 1980, the 13-part PBS series, which he co-wrote and narrated, was just a masterpiece of scientific outreach.
It wasn't just popular, it completely redefined how science could be presented on screen. It became the most watched series in American public television history until 1990.
And his motivation was deeply rooted in his frustration with the status quo. He was targeting a general audience because he felt the average person had lost interest in science because of what he called a stifled educational system.
So Cosmos was designed to reignite that childhood wonder he felt in the library.
Exactly. And they used incredibly innovative techniques like the cosmic calendar, which condenses the 13.8 billion-year history of the universe into a single Earth year. That remains a touchstone for science communicators today.
The show blended cutting-edge science, pioneering special effects for the time, and this profound philosophical narrative. And Sagan was the viewer's earnest, trustworthy guide through it all.
The accolades were immediate. 2 Emmys, a Peabody, a Hugo Award. Time magazine put him on their cover. He had arrived as a cultural superstar.
The thing that made him instantly recognizable, though, was his delivery. That measured, slightly breathy, and highly emphatic way of speaking, which also led to the single most famous misquote in science history.
Billions and billions.
Billions and billions.
Which is a fun detail because he never actually used that exact phrase in Cosmos. He preferred the slightly more dramatic billions upon billions.
Well, the parody stuck, mostly thanks to his unique verbal emphasis. We know he consciously emphasized the B sound when saying billions so people wouldn't mishear it as millions.
And that distinctive cadence made him irresistible to comedians. The most famous, of course, was Johnny Carson on The Tonight Show.
And his impression became iconic. But what's fascinating is that Sagan took this mockery in stride. He even titled his final book Billions and Billions and started it with a humorous discussion of the phrase's history.
He actually noted that Carson, who was an amateur astronomer himself, was quite clever, and his caricature often included a surprising amount of real, accurate science.
The popularity was so immense that, humorously, a Sagan became defined in scientific circles as an informal unit of measurement for any very large number of anything.
Beyond television, his output of popular science books was just immense. The Dragons of Eden, about the evolution of human intelligence, won him the 1978 Pulitzer. He also wrote classics like Broca's Brain and The Demon-Haunted World.
And we can't forget he dipped his toe into fiction once, the science fiction novel Contact.
Published in 1985, it was based on a film treatment he co-wrote with Andrean, and it was later adapted into that highly successful 1997 film starring Jodie Foster. The film itself won a Hugo Award.
But maybe his single most enduring and powerful piece of philosophical rhetoric is the famous pale blue dot reflection. And this moment was born from his direct request to NASA.
Yes, in 1990, at Sagan's urging, the Voyager 1 spacecraft, having finished its primary mission, turned its camera back toward Earth from a distance of 6 billion kilometers.
And the resulting photo showed Earth as just a single tiny bright pixel, a literal mote of dust suspended in a sunbeam.
His 1994 lecture based on this image and the book that followed, Pale Blue Dot, it's often taught in philosophy classes, not just science courses. The rhetorical power is immense.
He used that image of human insignificance to deliver this powerful moral message about the petty nature of human conflict. Think of the rivers of blood spawned by all those generals and emperors, so that in glory and triumph, they could become the momentary masters of a fraction of a dot.
And that perspective links directly back to the 5-year-old in the library. For Sagan, grasping the scale of the cosmos should logically lead to profound humility, and that humility should compel us to treat one another and our planet with kindness, given that this tiny, distant dot is the only home we have ever known. His science was the foundation for his morality and his activism.
That link between cosmic perspective and global morality really defines his final decades. Sagan was never content just to observe the universe. He felt he had to actively address the major problems on our mote of dust.
His scientific rigor often crossed directly into political activism, and it was driven by this deep, constant concern over humanity's capacity for self-destruction, a concern he often linked back to his thoughts on the Fermi paradox.
Right, the idea that maybe advanced civilizations just destroy themselves before they can reach the stars.
And that fear fueled his most high-profile political engagement. The nuclear winter hypothesis. This was at the absolute height of Cold War anxiety in the 1980s.
He became deeply involved in developing and publicizing what was called the TTIPS model in 1983. So for our audience, what exactly was the TTIPS model and what did it predict?
Well, TTIPS was an acronym for the authors Turco, Toon, Ackerman, Pollack, and Sagan. The model predicted that a massive nuclear exchange would inject vast amounts of dust and, crucially, soot from urban firestorms into the upper atmosphere.
And that soot and dust would block out the sun.
It would rise high enough to absorb and scatter incoming sunlight. This layer would create an optical depth that would plunge the Earth into prolonged darkness and freezing temperatures. A global winter.
The prediction was for cooling far more intense and prolonged than simple dust would cause, leading to catastrophic agricultural failure, global starvation, even for nations not directly involved in the war.
And Sagan used his immense media platform to get this information out, making him a central figure in the anti-nuclear movement. But this level of advocacy generated a massive backlash from his peers.
It did. Many in the scientific community felt he was overstating the certainty of the model for political ends. He faced really serious public disdain, especially from hardline figures like the nuclear physicist Edward Teller.
The father of the H-bomb.
Teller's critique was scathing. He basically called Sagan a sensationalist. He said, "A propagandist is one who uses incomplete information to produce maximum persuasion. I can compliment you on being, indeed, an excellent propagandist."
It was a very public, very high-stakes battle. Sagan and his colleagues later slightly revised the severity of the cooling down to nuclear autumn, but the core concept, that a limited nuclear exchange could devastate the global climate, that held.
And his integrity was tested again in 1991 during the Gulf War. Saddam Hussein threatened to light Kuwait's oil wells on fire, and Sagan and his team warned that if those fires burned for months, the smoke could disrupt agriculture in South Asia.
The fires did burn for months, and the prediction became a subject of heated scientific debate. And to his eternal credit, when he reviewed the data later, Sagan publicly conceded that he had been partially wrong about the global effects.
In the demon-haunted world, he noted that while local temperatures did drop by 4 to 6 degrees Celsius over the Persian Gulf, the smoke didn't reach the crucial stratospheric altitudes they had predicted.
So Asia was spared the continental cooling effect. And that intellectual honesty, the willingness to admit error when new data contradicted his prediction, even after a huge public debate, that's critical. It distinguished his activism from mere propaganda. He applied the same rigor to his own claims as he did to anyone else's.
Shifting back to space, he was a vocal proponent for an organized search for near-Earth objects, or NEOs, that pose an impact threat. But here, too, he saw a dangerous political dilemma.
This is what he called the deflection dilemma. He argued that the very technology you'd need to safely deflect a threatening asteroid away from Earth, say, a precise delivery system with a nuclear detonation.
In the hands of a hostile power, that could be used to divert a non-threatening object toward Earth.
Exactly. The global defense mechanism becomes the ultimate weapon of mass destruction.
So he saw this double-edged sword as a catalyst for political reform.
He did. He argued that the existence of this dual-use technology required international accountability and oversight, forcing maturing international relations as a necessity for global survival.
And at the root of all of his work, both scientific and political, was this almost missionary commitment to skeptical inquiry. He wanted everyone, not just academics, to adopt the tools of science.
This is the driving force behind his famous baloney detection kit, a set of tools he laid out in the demon-haunted world for critical thinking. It was designed to defend against pervasive pseudoscience, superstition, and faulty reasoning.
And central to this kit is the dictum that is now universally known as the Sagan standard.
Extraordinary claims require extraordinary evidence. It is the single most quotable summary of scientific skepticism.
And what's a great nugget for you, the listener, is the intellectual lineage of that standard. Sagan popularized it, but the concept is much older.
Indeed. You can trace it through figures like sociologist Marcello Truzzi in the 70s, but its purest form is the principle of Laplace from the early 19th century. Pierre-Simon Laplace stated, "The weight of the evidence should be proportioned to the strangeness of the facts."
Sagan just took that rigorous standard and made it accessible and memorable for the entire world, and he applied that skepticism ruthlessly, even against historical giants like Plato.
His critique of Plato was profound. It was a critique of the historical separation of mind and matter. Sagan criticized Plato for believing that abstract ideas were far more real than the natural world, and, crucially, for advising astronomers not to observe the stars and planets.
He felt this Platonic disdain for empirical observation basically extinguished the light of science and experiment that had been briefly kindled by earlier Greek materialist thinkers. For Sagan, science was observation and testing, not just abstract thought.
And applying that skepticism to the modern world, let's talk about UFOs. He was personally fascinated by the 1947 flying saucer craze as a young man.
But his adult scientific view was consistently skeptical, yet nuanced.
Very nuanced. He strongly rejected the prevailing extraterrestrial explanations for UFOs. He argued there was simply no physical evidence that met the Sagan standard. However, he believed the phenomenon was a completely legitimate subject for scientific study, mainly because of the massive public interest.
He urged the government to declassify all files, stressed that transparency was key.
But he cautioned against jumping to the conclusion that the files contain suppressed evidence of alien visits.
Finally, let's turn to his complex and sometimes surprising personal beliefs, beginning with his views on spirituality and God.
Sagan consistently defined himself as agnostic. He was intellectually honest in stating that he knew of no compelling evidence for or against the existence of God. He flatly rejected the traditional anthropomorphic concept of God as an oversized white male with a flowing beard. He found that notion ludicrous.
His preferred concept leaned more toward philosophical naturalism, echoing thinkers like Spinoza and Einstein.
Right. He viewed God as essentially the sum total of the physical laws which describe the universe. But he acknowledged the emotional shortcoming of that view. He famously added that this God is emotionally unsatisfying. It does not make much sense to pray to the law of gravity.
Yet, he believed science itself could be a source of spirituality.
A profound source of spirituality, he called it, rooted in that overwhelming sense of elation and humility combined when one grasps the true scale of the cosmos.
And then there's the most surprising personal revelation, which we only learn about after his death.
Hmm.
His long-standing advocacy for the use of marijuana, published anonymously as Mr. X.
This was in 1971 in the book Marijuana Reconsidered, and he published anonymously precisely because of the academic climate. In 71, admitting to cannabis use would have instantly destroyed the credibility he was trying so hard to build.
Especially after the Harvard tenure debate.
Exactly. As Mr. X, he claimed that cannabis was a tool for intellectual and sensual enhancement. He said it helped him appreciate art, enhance intellectual experiences, and even provided inspiration for some of his scientific work by allowing him to see connections and patterns he might otherwise miss.
This revelation just adds this crucial depth to the portrait of Sagan as a constant intellectual explorer, willing to risk professional scorn for the sake of expanded experience.
And the connection is cemented by the fact that after his identity was revealed by his friend Lester Grinspoon following his death, his widow, Anne Druyan, went on to preside over the board of directors for NORML, the National Organization for the Reform of Marijuana Laws.
Carl Sagan died in 1996. He was relatively young, only 62. He succumbed to pneumonia after a brutal battle with myelodysplasia, a type of bone marrow cancer. He underwent 3 bone marrow transplants from his sister before his body gave out.
His life was this unique and powerful bridge between highly specialized research planetary science, astrobiology, and the public. And it was all driven by this profound conviction that asking fundamental questions is the highest human calling.
His legacy is secured not just in the science he confirmed, but in the millions of people he inspired to just ask, why?
He was the intellectual force who made the cosmos feel like home, urging us all to look up with humility, but also to look at ourselves with rigorous skepticism.
And of course, we can't close this deep dive without the amusing anecdote that perfectly captures the clash between his celebrity and his demand for respect, the Apple incident.
A classic. In 1994, engineers at Apple Computer codenamed their new Power Macintosh 7100 computer Carl Sagan, and they were openly joking that the machine would earn the company billions and billions.
And Sagan, ever the stickler for ethical boundaries and concerned about an unauthorized endorsement, sent Apple a cease and desist letter.
And the engineers, in a fit of, classic tech rivalry pettiness, internally retaliated by temporarily changing the code name to BHA,
which stood for Butthead Astronomer.
It was a tense moment, but eventually, an out-of-court settlement was reached. Apple issued a very conciliatory public statement expressing their great respect for Dr. Sagan. So despite the friction, his name literally crossed over from the stars to our desktop computers.
And his name endures far more formally in space itself. The landing site of the Mars Pathfinder was renamed the Carl Sagan Memorial Station in 1997. And a main belt asteroid is named 2709 Sagan.
And in the most moving reflection after his death, his wife, Anne Druyan, just perfectly encapsulated their life together and his deep naturalistic beliefs. She noted that knowing there was no afterlife, no guaranteed reunion, made their time together all the more precious. She said, "I don't think I'll ever see Carl again, but I saw him, we saw each other, we found each other in the cosmos, and that was wonderful."
That appreciation of the preciousness of connection, defined by reason and wonder, is a profound summation of his life's philosophy. He didn't just teach us about the stars. He taught us how to live here on Earth.
So, as you reflect on Sagan's life, the curiosity of the 5-year-old in the library, the professor who rejected secrecy, the advocate who demanded intellectual honesty, we'll leave you with this final, provocative thought. When you're confronted with complex claims and competing narratives in your own world, what specific extraordinary claims are you applying the Sagan standard to? And what evidence by that high bar are you demanding?